Crash Course Instrumentation, Saturday Special Episode 7, From Sparks to Sensors, The History of Electrical and Process Measurement. Ever wonder how we learned to measure the invisible? Electricity, pressure, temperature, flow. These things aren't just hard to see. They're impossible to see. Yet we measure them every day with incredible accuracy, helping us control factories, launch rockets, and brew your favorite cup of coffee. In this crash course, Instrumentation Saturday Special, we're diving into the electrifying history of electrical and process measurement, from ancient static sparks to smart sensors in the cloud. Part 1. Ancient Curiosity and Early Sparks. The story begins over 2,000 years ago, when Greek philosopher Thales of Miletus noticed that rubbing amber with fur caused it to attract feathers and dust. This strange, invisible force would later be known as static electricity, and it fascinated thinkers for centuries. Fast forward to the late 1700s. Italian scientist Luigi Galvani noticed frog legs twitching when touched by different metals. Weird? Yes. Groundbreaking? Absolutely. His work led to Alessandro Volta's invention of the voltaic pile in 1800, the world's first true battery. That battery made it possible to generate and control electricity on demand, and opened the door to measuring it. Part 2. Birth of the electrical meter. The early 1800s brought a scientific gold rush. André-Marie Ampère discovered how electricity creates magnetic fields. Georg Ohm figured out how voltage, current, and resistance are mathematically related, and gave us Ohm's law. Soon after, German scientist Johann Schweigger invented the galvanometer, a simple device that used a moving needle to detect small currents. It was the first instrument to make electricity visible. These needle-style meters would evolve and become essential in everything from lab research to Morse code telegraphy. Part 3. Industrialization and instrumentation. As steam engines, factories, and electric lighting took over the 19th century, engineers needed better ways to measure and control their systems. This gave rise to analog panel meters, large, rugged meters installed on walls, panels, and switchboards. Edison's power plants, for example, used early voltmeters and ammeters to monitor DC generation and distribution. Meanwhile, in process industries, measurement got mechanical. The Bourdon tube, a curved metal tube that straightens under pressure, became a staple for reading steam pressure. Thermocouples soon followed, allowing technicians to measure high temperatures with nothing but two different metals. Part 4. The rise of process measurement. By the early 20th century, factories and refineries were full of gauges, dials, and paper chart recorders. Pneumatic controllers using 3 to 15 psi signals allowed processes to be automated without electricity. As electronics advanced, these systems gave way to the famous 420 mA current loop, which became the global standard for transmitting analog measurement signals. Why 4 to 20? The 4 mA live zero let techs know if a transmitter was powered or dead. Smart, simple, and still used today. Operators relied on circular chart recorders, spinning paper discs marked with pen traces, to monitor everything from pressure and temperature to flow and level. Believe it or not, some facilities still use them today. Part 5. The Digital Revolution. In the 1970s and 80s, digital tech changed everything. Handheld, digital multimeters, DMMs hit the market, combining compact size, rugged durability, and incredible accuracy. Companies like Fluke became industry legends. In the process world, smart transmitters with microprocessors enabled new communication protocols like HART and Foundation Fieldbus. Now, instruments could send and receive data, enabling diagnostics, remote calibration, and faster troubleshooting. Today's systems feature wireless sensors, IoT connectivity, and cloud-based dashboards. But they're still built on principles discovered over a century ago. Part 6. Why it all still matters. From amber and frog legs to AI diagnostics, measurement has come a long way. But some things never change. Voltage still pushes current, resistance still limits flow, loops still carry analog signals, and smart tech still depends on smart technicians. Understanding the why behind the what makes you a better tech. It helps you spot problems faster, calibrate equipment with confidence, and troubleshoot systems others struggle with. Every time you clip a probe onto a terminal or check a pressure transmitter, you're part of a legacy of innovation, a legacy built by curious minds solving invisible problems. Thanks for watching this Crash Course Instrumentation Saturday Special. If you enjoyed the ride, hit like and subscribe. For more bite-sized lessons and deep dives, check out our playlist and join the conversation in our Facebook group. Special thanks to Tony Kuphaldt and the open source community for the Mod-L instructional series. You can explore all the models at ebiblio.org/Kuphaldt/Socratic or model.